Hello prospective King of the 6th students, and welcome to the introductory maths video on solving quadratic equations. We're going to be looking at three things in this video: what we're trying to do when we solve a quadratic, and then two ways of finding the roots or the solutions of a quadratic, either by factorisation or by the use of a quadratic formula. So let's get the ball rolling by having a look at our first quadratic equation. X squared minus 2x equals x minus 2. To solve this equation, we are trying to find the values of x which cause x squared minus 2x and x minus 2 to have the same value. If we look at our graph, we can see the red curve, y equals x squared minus 2x, and the blue curve, or blue line rather, is y equals x minus 2. And we can see that they have the same value, and so the same x coordinates, where they intersect. So the solutions for our quadratic equation are either going to be x equals 1 or x equals 2. That's all well and good if we can accurately draw a quadratic equation and the roots are nice integer numbers like it is here. However, quite often, usually in fact, that's not the case. And if we could try to solve a quadratic equation just by dividing through, adding, subtracting, and square rooting, we will never be able to get just an x on one side and just a number on the other side. So, what can we do? Well, we can't rearrange it to get x on one side and a number on the other side, at least without doing things like factorising. But what we can do is rearrange our equation to make it equal to 0. So we could have, if we subtract x from both sides and add 2 to both sides, we could have x squared minus 3x plus 2 equals 0, just by rearranging it. And if we have a look here, the purple line is x squared minus 3x plus 2. Now if we look very carefully at it, what we should notice is that the points where x squared minus 3x plus 2 cross the x-axis correspond to the x-coordinates of the intersection between x squared minus 2x and x minus 2. Now this shouldn't be a surprise, since they're solutions of the same equation. So, if we can find the x-coordinates where our quadratic, once it equals 0, if we draw the graph of y equals that, if we can find where that crosses the x-axis, that gives us where it's equal to 0. So the solutions to this will be the same as our solutions to this. Now, as I said a second ago, it's all well and good if we can draw our graphs accurately, or if our solutions are nice numbers. But what if we can't? So we have to look at a couple of different methods for doing that. And these methods will be looking at finding ways of going through and solving a quadratic when it's equal to 0, because we know that that will give us the roots of our y equals quadratic, and we know that those roots will be the solutions to our original quadratic equation. And this is why when we solve a quadratic equation, quite often the solutions are referred to as the roots or the zeros, because they're the points at which the quadratic is equal to 0, therefore they'll be the roots of our equation. So, without any further ado, let's have a look at doing that. So, we've got x squared minus 3x plus 2, and the first thing I want to do is factorise that. So, you know what? You guys already know how to factorise a quadratic, so do you want to pause the video for a second, have a go at factorising it, and then press play again? No, I really did mean it. Pause it, have a go at factorising it, and then press play again. Okay, I'm assuming you've now paused it and had a go at it. So let's have a quick go at factorising this beastie. We've got an x squared term, so we're going to have x and x equals 0. And we need two numbers that multiply together to give us 2 and add together to give us minus 3. So I reckon that's going to be minus 2 and minus 1. Now what you'll notice here is we have two numbers, x minus 2 and x minus 1, that multiply together to make 0. What that means is that one of those two numbers must equal 0. So either x minus 2 equals 0, in which case x equals 2, or x minus 1 equals 0, in which case x equals 1. So our solutions to our quadratic equation are going to be x equals 1 or x equals 2. Now you'll notice I don't say and because x can't be 1 and 2 at the same time, so we must say or. Okay, so our first method for solving quadratics then is first to make them equal to 0, and then to factorise the VC, and then take both those factors, so in this case x minus 2 and x minus 1, make them equal to 0, and then solve those linear factors, solve those linear equations. Okay, do you want to pause it again, and then have a go at solving x squared equals 2x using this method? Okay, see you in a couple of minutes. Okay, I'm assuming you paused it and had a go at solving it, so let's quickly whip through that to make sure you did it right. So what have we got? We've got x squared equals 2x. First you need to make it equal to 0. So we get x squared minus 2x equals 0. Now you'll notice there's only two terms in this quadratic, whereas before we had 3. That actually makes factorising it a little bit easier, because one of our factors is just going to be x. And then we're going to have x minus 2 equals 0. Now we've included this deliberately because what we often find is that quadratics like this that factorise with a linear term and just an x or some multiple of x tend to throw people for some reason. So make sure I included it. So then, that means that either x equals 0, so we get 0 times minus 2 is 0, or x minus 2 equals 0, so x equals 2, in which case we're going to get 2 times by 0, which is 0. So therefore, x equals 0 or 2. Okay. So that's how we go about solving quadratic equations, or at least those we can factorise easily. So what I want you to do now is pause the video and have a go at solving these 3 quadratic equations. No, go away and solve them, go on. Okay, I'll assume you've gone through and solved those equations. You'll probably want the answers. The answers are there. So for the first question, x is either minus 1 or minus 2. The second one, x is either minus 1 or 4. And the third one, x is either minus 5 or 3. Okay, moving on then. We said that, okay, moving on then. So we know that not all quadratics factorise. Okay, in that instance, we need to use another method. Now, normally at this point, I'll tell you to use completing the square. However, our preparation homework doesn't cover completing the square. I know you did it at GCSE, but you should have done it at GCSE. And it's grade A material at GCSE, I believe. And it's a bit of bread and butter maths you actually need for A-level maths. And you will be taught it again at A-level. However, we're not covering that at the moment. So what we're going to go straight to is using the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. If you don't know where it's come from, if you weren't shown at GCSE where it comes from, which you may not have been, if you look somewhere on the screen or in the description bar, there will be a link to a video where I've gone through and derived it by completing the square. But that's beyond the scope of this video. So what we want to do is we want to solve 2x squared minus 5 equals 7 minus 3x. Okay, so just like before, we make our quadratic equal to 0. Firstly, because that enables us to factorise it, and then make those two factors independently equal to 0, if it factorises. And if it doesn't, it enables us to use our quadratic formula, because the quadratic formula is derived from having ax squared plus bx plus c equal to 0. So let's go about doing that. So we have to add 3x to both sides. So we can get 2x squared plus 3x, and we have to subtract 7 from both sides. So minus 12 equals 0. Okay, first thing we should do is go through and try and factorise that. I'm going to save us the bother though in this particular instance and say it doesn't factorise. Okay, so in that case I want to use the quadratic formula. I want to use x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So I need to work out what a, b and c are. So if I compare this to this, a is going to be 2. B is going to be 3. And C, and this is where people tend to make some slight mistakes, is going to be minus 12. Okay, and we're going to substitute that into a quadratic formula, and from that get a solution. What I'd like you to do is at this stage go through and have a go at doing that. So pause the video, have a go at doing that. Try not to use a calculator. If at all possible, in the first instance, leave your answer in surd form. Okay? Once you've got it as a nice surd, then use your calculator to get the exact value. Okay, thank you very much. So pause it. Go on, pause it. Okay, I've assumed you've paused it. And so I'll quickly whip through how to do this beastie. So we're going to have x equals minus b, so that's minus 3, plus or minus the square root of b squared, so 9, minus 4 times a times 2, times by c times minus 12. All over 2 times 2. So what does that give me? That gives me minus 3 plus or minus square root of 9, 2 negatives plus 4 times 2 is 8. 8 times 12 is going to be 96. All over 4. So that gives me minus 3 plus or minus the square root of 105 over 4. Does the square root of 105 simplify at all? 105, 5 will go in 21 times, and 21 is 3 times 7. Nope, it has no square factors. See, I taught you factor decomposition for a reason at GCSE. So there we have it. X is going to be minus 3 plus or minus the square root of 105 all over 4. Now in your Core 1 exam, that's how you leave your answer, because Core 1's a non-calculator. However, later on, you will be able to calculate it, and sometimes you will want to go through and find a approximate answer by using a calculator. So I'll quickly bung it in the calculator and see what we get. So that gives us either 1.81 or minus 3.31. Okay. So, as I have alluded to, using the quadratic formula is a last resort method for solving quadratic equations. And the reason for that is that it can be an awful lot of work. Usually, if a quadratic equation will factorise, you're better off factorising, it will be less work. Also, you need to be able to factorise quadratics and things for algebraic manipulation. So Core 1 is about getting your algebraic skills up to scratch, to be able to handle A2 maths. So by going through and always trying to factorise your quadratics, you're practicing doing that. You're practicing a skill that you're going to need to have. Okay, so If you want to have a go at the rest of the exercise, pause the video now, give those a go, press play, and the answers will appear. Okay, so pause now. Okay, I hope that didn't take you too long to do. So the answers are here. Okay, I hope that was useful. I hope you don't have any problems with it. Thank you very much for listening. If you liked it and like my videos and find them useful, please like and subscribe. Thank you very much.